And the last chapter of this book is an agnostic approach. At this point, we have explored serverless architectures using 3 cloud providers: Amazon, AWS, Microsoft Azure, and Google Cloud. We have created applications that use HTTP triggers and storage triggers and respond to them by making changes to the provider-specific services. Through these exercises, we have seen many use cases for these types of applications and provider-specific use cases. In this chapter, which is called Agnostic Approach and Agnostic Approach, in this chapter, we will take a step back and look at how to create solutions that are independent on the specific provider. We will explore use cases and examples of application architectures that remove the provider-specific logic from the functions and leverage the universality of the serverless code to provide completely agnostic solutions. Note, you will need a basic understanding of how each of the provider services work in order to complete the exercises in this chapter. If you have not gone through the examples of the 3 providers, please do so. If you want to skim this chapter, please complete with me. If you want to apply each single one, you have to go through the entire series of videos, go to the playlist of this book, which is called Beginning Serverless Computing, published in 2018. Go through the entire book. Then when you reach this point, you are good to proceed. And if you want to study it, then try to apply everything you see. My goal is to skim the book, to browse it, to go through it really quick, to have an idea, generic understanding. In this chapter, we will spend some time discussing the need for agnostic solutions. So agnostic solutions are the universal solutions that are not really depend on a cloud solution or another. It can apply to all. What that means, okay, let me reread this. In this chapter, we will spend some time discussing the need for agnostic solutions, what that means for future serverless applications, the approach that we will have to use to present a solution, the code we will use to create the solution, and a serverless example using a database trigger. Need for agnostic solutions. Before we begin developing an agnostic solution, I think it's important to identify why this is such an important concept to tackle and why it is even worth approaching. I'm going to start by identifying a current case study I have deployed for my client, a global insurance company. So the author deployed a global insurance company case study, and we will start identifying it. Why? To explore the need for the agnostic solutions. The current state. My client is a world leader in the travel insurance and assistance industry. They help people anytime, anywhere to find solutions to any travel-related problem. Their partners number in the thousands and include travel agencies, airlines, resorts, websites, even ticket brokers, corporations, universities, and credit card companies. Right? This company is owned by the world's largest diversified insurance company, thanks in large part to the scale of its parent company. It is able to provide innovative products with the worldwide coverage at a competitive rate. Over 25 million travelers depend on this company every year to protect them while they are away from home. It provides a wide range of insurance and concierge services that can help its customers to get the most out of the trip. The company has been helping protect the fabric of America for more than 100 years. In fact, this client insured the Wright brothers' first flight, the construction of the Golden Gate Bridge, and many Hollywood movies. With this reputation and amount of services and clients involved, this client places a lot of importance to its technical stack and architecture. With the current state, the company is currently involved with one cloud provider, but most of its infrastructure is in-house. Most of its infrastructure is in-house. Management wants to move the entire infrastructure to the cloud, but with so many dependencies and a headquarter abroad, that is obviously easier said than done. The company's first step toward the transition to the cloud has involved a starter application that automates claim payments for trip delays and cancellation. The proposed architecture for this solution involves several AWS Lambda functions and many services in AWS. There are four major parts for this execution that are detailed in Figure 6.1, which is this one. CSV load flow, and here's the step one. Airline departing, airplane, flight number, flight date, delay. And this figure demonstrates the transfer of data from one premises to the AWS Lambda functions. Then it goes to the Amazon S3. S3 triggers parse CSV function. Parse CSV function processes row by row and triggers write to RDS function. Parse CSV, write to RDS function. Call flight state function. Flight state API. The keys are shown here, and we have step 4 and step 5, step 3 and step 4. All right. The current architecture with this cloud solution involves communicating between an on-premises database. On-premises means in-house, right? Database, and an AWS database between the in-house and the cloud. The on-premises side still stores all of the customer's flight data that is needed to make this application work. On top of this, the changes required to make this transition are not simple changes. There are company-wide changes that require a lot of time, resources, and process training. Even providing a simple CSV file requires approval by headquarters security and the entire IT department. This is very standard across industries. Figure 6.2 shows the notification workflow, which takes for an incoming flight state request such as delay or cancellation. Delay or cancellation comes from the flight state API. Flight state sends notification to API gateway, then goes to Amazon API gateway, then goes to the query flies function as step 2, then goes to step 3 to trigger notify event function to notify event, and goes to the Amazon RDS and goes to write to RDS function, then goes without field contract ID and with field contract ID. And here's we have PeopleSoft and ABS. Yeah. So the notify workflow demonstrates the flow of data from the flight state API back to the Lambda functions that handles the flight data. The notify workflow, similar to the CSV flow, relies on communication with the on-premises database to be successful. It also relies on a data transfer and update in Amazon RDS to send the appropriate data back to an on-premises database. Figure 6.3 demonstrates the SMS workflow, which takes a number and text message from the on-premises database and sends a text to the customer. So we have the SMS workflow. And step 1 is from PeopleSoft, Amazon API Gateway. API Gateway triggers Lambda function. Then we have the Lambda function. AWS Lambda calls SNS via SDK. And we have Amazon SNS that works similar to Twilio and it sends text messages. And step 4, AWS SNS sends a message via SMS and comes to the user's phone number, right? And this is the SMS flow demonstrates the ability of the application to notify customers when a flight has been delayed or canceled, to the extent that a claim can be filled automatically. Once again, the flow depends on the internal data flowing in and out to be able to text the customer with their flight delay and cancellation information. The next flow update the table information in the on-premises database to be cleared every 2 weeks. This is triggered by a cloud watch timer that executes a Lambda function that reaches out to the on-premises system to clear out the old and updated flight data. Figure 6.4 demonstrates this process. 6.4. Update table workflow. AWS CloudWatch, AWS Lambda, and PeopleSoft, and just like that, right? Step 1, CloudWatch triggers the Lambda function every 2 weeks. Step 2, the update Lambda sends a GET request to FS. And we have step 3, FS return airlines and airport to the Lambda. Step 4, the update Lambda sends this data to PS, PeopleSoft. The bottom line with all of these, flows and processes within the new architecture is that they depend on both on-premises infrastructure and the AWS infrastructure. While it is very well-designed system and a great idea from a customer standpoint, there are many concerns from a business and overall architecture standpoint. So there are many concerns. Business problems. We will go through that. And we will go through recommended solutions, right? Then we'll go to define an approach. Then we'll see proposed solution. All right. Then we will explore the code. Then we will go through this note. And code an example using the database. And we have improving our serverless solution using environment variables and enforcing models, right? And the final step will be the conclusion, and the book will be over. Then we'll have the index. In the next video, we'll go through that in details. This is just an overview. So in the next video, we will continue from from business problems. We will read from here till the end of the book. All right, and that the next video will be the very last video in this book, and we'll be done.